All right, we're moving on now to section 10.2, graphing quadratic functions. And these are pretty neat here. So we're going to be graphing these functions right here. Before that, so what I've done right here is in blue, I've graphed f of x equals x squared. Okay, and so I use the x coordinates -3, -2, -1, 0, 1, 2, 3. Okay, so there's -3, -2, -1, 0, 1, 2, 3. And just notice what the y values are. So when the x value is at -3, the y value is at 9. When I'm at the x value -4, I'm at -2, I'm 4. This is 1, 0, 1, 4, and 9. Okay. What I want you to notice is, first of all, that this line right here at 0, 0 cuts it in half. So every parabola is always going to be, or it can be cut in half. So the line that cuts it in half, and so if I were to have a dotted line like right here that kind of cuts this in like half, this line right here would be called the axis of symmetry. That's what this guy right here is called. It's called the axis of symmetry. Okay, and this lowest number right here on this parabola is called a vertex. Okay, and we are going to be graphing parabolas that are upside down, that open down, and those are called the vertex. Is basically the highest or the lowest point of a parabola. So just a little bit of a terminology right there. This is the axis of symmetry. That right there is the vertex, and this U-shaped graph is called a parabola or a quadratic. They mean the same thing. And you know from looking at the equation of the graph that it's going to be quadratic because the highest degree is a power of 2. Okay, if it has a power of 1, then it's linear. It means it's a straight line. If it's a power of 2, then it's going to be a quadratic. Okay, and then again, that's the highest degree is 2. If it has 2 and 3 in there, then that's not going to be the case. So, all right. So what we're doing right here is that we want to graph these guys over here. And I want to show you a really neat shortcut to graphing these. So that means you don't have to do, you don't have to do a table every single time that you graph these. There's actually a very, very, very quick way of graphing these. And I'm going to show you what that is right now. All right, so check this out. When we're graphing x squared plus 1, notice that if you take away the 1, then it's just x squared, meaning that it's this right here. So the only thing that you have to do when you graph x squared plus 1 is check this out. If it says plus 1, then I move the vertex up 1 unit. So if I take the vertex and then if I move it up 1, then this is what it's going to look like then. Oh, I guess I'll just grab the coordinate plane then. That's fine. So see, it went from the original and then now it is moved up 1. Okay, so that would be the graph of x squared plus 1. Look at x squared minus 3. Well, if you go back to the original, okay, so that's the original right there. And just get rid of this right here. All right, so if you look at the original graph right here, and then if you graph x squared minus 3, you move the original graph down 3 units. So 1, 2, 3. That would be the graph of x squared minus 3. Now what about f of x as x squared plus k? What does the k do to the graph? That's basically what I want us to learn in this lesson, is what does the k do? So whatever k is, what is it doing to the graph? Well, it's doing this. It's taking the original graph, this is our original graph, and it's moving vertically up and down the y-axis. That's all it does. So that's why this is called a vertical shift. So what does the k do? It gives it a vertical shift. Okay?